So here we have yet another example of an inner and outer situation. I just wanted to show you that at some point you kind of stop writing what f and g actually are. You just start recognizing the inner and outer functions and you work from the outside in. So here's the way you think about this. We have is ln of sine x. Now we know that the derivative of ln x is equal to 1 over x, right? So what that means is that the way you want to think about this is you're taking the outer function and then treating this thing just like it's an x. So this is going to equal, just for the same reason that the derivative of ln x is 1 over x, the derivative of ln sine x is 1 over sine x. But then there's an extra step to do because the thing inside here was not an x. So now we're going to multiply by the derivative of sine, which is cosine x. So this is actually equal to cosine x over sine x, which equals cotangent of x, although I certainly would have accepted that as an answer. So the thing to recognize here is that if I had defined what f and g are, I'm trying to get away from that, then we'd say that f of x equals ln x, g of x is equal to sine x. So then f prime of x equals 1 over x, and g prime of x equals cosine x. You'll see in that case that what I have here is this is actually f prime of g. Take a look at what f prime is, take a look at what g is, and convince yourself that f prime of g is this, and then this is g prime. So the point is that you at some point you stop writing out what the f and g are, and you just get used to the idea of working from the outside in to do these functions, like to find the derivatives of these functions, just like I did. Now, I want to just do a little aside here because this is the point where you might start to ask, why is the rule any different? In other words, if the derivative of ln x is 1 over x, why isn't the derivative of ln sine x just 1 over sine x? Why is there a different rule depending on what's inside? The interesting thing is there's actually not, because if I were to take f of x, let's say, let's suppose that I want to find the derivative of ln of x. Well, in that case, what I could do is I could say that x itself is just the inner function, and ln of x is the outer function. So what I could do is I could say that this is going to equal 1 over x times whatever the derivative is of x. But what's the derivative of x? We all know how to find that. That's just equal to 1. So this is equal to 1 over x times 1. In a sense, every problem is really a chain rule problem. It's just that when the inside function is x, the last thing that you're doing is multiplying by 1. So you just don't see the chain rule step in a normal problem. It's only when I put one function inside another that you actually have to pay attention to what g prime is. Because if g, the inner function, is just defined to be x itself, then its derivative is 1, and you never see the g prime part of the chain rule. So I don't know if that makes it easier or harder to understand what the chain rule is, but that's sort of the more conceptual understanding of what we're doing, and I think that it's easier when you stop seeing the rules as just different just different balkanized rules that have nothing to do with each other. They're really all part of the same system.